Alright, this lesson right here is going to continue on the linear systems. Now, we know that a linear equation is going to be, if you're lucky, it's going to be y equals mx plus b. That would be this form right here. But sometimes they're going to give it to you in a form that looks like this. And that's not that easy for us to graph because, we want to get the slope and we want to get the y-intercept. Okay? So what do we do here? We rearrange it. We're solving for the y. And so we have to get rid of this. So what we're going to do is we're going to add 3x to both sides. That's going to cancel this. And we're going to have y equals this. They're not like terms, so you're just going to have to write 3x plus 2. Or, you can also write y equals 2 plus 3x, but when we're graphing, you need to understand that this is the slope. The slope is going to be the number that's in front of the x, and this is the y-intercept. Okay? Same thing here. Slope, y-intercept. Okay? And so it doesn't really matter how you write it as long as you understand that this coefficient is your slope. And so with that, we can definitely graph it. They can give you something like this. And let me clear this. So let's say, for example, they give you something like 2y minus 3x equals 7. And I made this as ugly as can possibly be. Now you're looking for the y. Okay, why isn't this writing? You're looking for the y. What's the first thing that's closest to the y? The 2. And then the minus 3x. What's going to go first? That which is farthest away from the y. So the minus 3x is the one that has to go. Okay? So you're going to add 3x to both sides. Okay? That crosses out. And you're left with 2y equals, remember what I said, this can either be 7 plus 3x or 3x plus 7. Alright, we're not done yet. We have to get rid of the 2. So we have to divide by 2, but then we have to divide everything by 2. The 3x and the 7. Okay? These 2's cancels, and now we have y equals 3 halves times x plus 7 halves. Okay? The slope is this, and your y-intercept is this. Okay? Alright, so now let's learn about techniques on solving systems of equations. Now you were introduced to 4 different techniques. You can, number 1, you can solve by graphing. Whoa, where's the H? It won't come out. Graphing. Okay, I don't know why it won't write over here. Now it's writing. Number 2, and by graphing we mean by making a table. Table of values, okay? Or you can solve it algebraically. Algebraically is the one that we like in class the most. And there's 2 techniques that you need to learn. The first one is substitution. And the other one is elimination. We're definitely going to go over those. Alright, the next thing that we need to talk about is the types of solutions that you're going to get. And there are 3 types of solutions that you're going to get. So if you have 2 lines, right? 2 lines will either, I'm going to draw the x-axis in black. There's 3 different cases, 3 different things that can happen. Your 2 lines will either intersect, okay? They will intersect, which means that they have different slope. You're going to get one solution. Right, so you're going to get an x and a y value as a solution for this. Now the thing about this system is that we're going to say that this system is consistent because there's a solution that exists, and it is independent, which means the equations do not depend upon one another. Okay? Now what can happen over here is that you can have a system like this. That's the first line, and then, oh no, it's supposed to be on top of it. You can have the other line, and they're supposed to be on top of each other. So basically the two lines, both lines are the same. That means they have the same slope and they have the same y-intercept. We say that this system is consistent, but it is dependent. And heads up, when you solve something like this, the variables cancel out, and you get something like 7 equals 7, or 5 equals 5, or -2 equals -2. Right, and when you get something like this at the end, you know that this is the case of two, the same line on top of each other. It's a consistent dependent system, and we say that we have, over here we have one solution, right? Over here we have an infinite number of solutions. And the last case would be the case where you have two lines that never, ever, 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 they will never touch each other because they are parallel. And if two lines are parallel, they will never touch each other. And if they don't touch each other, there will never be a solution to this. Remember, the solution is where the lines intersect, okay? So there is no solution. We say that this system is inconsistent. And how do you know when you have this case? You have this case when they have the same slope, but different y-intercept. And when you're solving the system, what does it look like? You get weird stuff like -3 equals 0, or 7 equals 5, and stuff that doesn't make any sense. And then all your variables cancel. And then so you know you have the case of no solution. Alright, so recapping, there's three types of solutions that you're going to get, or three different cases that you're going to see. Case 1 is going to be the case where the lines do cross each other and you have one solution. It's consistent and independent. The lines overlap. They are the same line, same slope, same y-intercept. It's consistent, but because they overlap, we call it dependent. And you have an infinite number of solutions. Or you have the case of parallel lines. Alright, so we can say this is case 2 over here. I can't write, I have no more room. Can I erase? Let me see. Ah, I got rid of it. It came back. I'm so glad I know how to do this. Don't make fun of me. Alright, I'm back. Case 2. That would be case 2, and this is case 3. Right? That's the case of no solution. Alright, thank you. In the next video, I'm actually going to start solving the problems now.